Hello, my dear students, and the rest of the learners. Welcome to part 7 in C++ computer programming series, in which we are going to learn about iterative control structures. My name is Mema JM, or you can simply call me Emily Swap. Iteration is the repetition of a statement or a block of statements in a program. C++ has 3 iterative statements, which are the while statement, the do-while statement, and the for statements. The iteration statements are also called loops because of their cyclic nature. Let's begin by looking at while structure. While statement. This structure, which is also called while loop, provides a way of repeating a statement or condition holds. Its syntax is while expression do the following. So that is while expression statement. What does that mean? It simply means that execute a set of statements if the expression is tested and it evaluates to true. So repeat a set of statements. Repeat execution of some statements for as long as a certain condition is holding true. So a condition is tested first, and then some activities take place or execution of statements take place. So while the condition is true, or a certain condition or a certain expression as evaluated true, execute a block of one or more statements. The first expression, called the loop condition, is evaluated. If the outcome is non-zero, then the statement called the loop body is executed and the whole process is repeated. In other words, if the condition evaluates to true, the block of statements just there are executed and repeated for as long as the condition is holding true. Otherwise, the loop is terminated. So if the condition is tested and it evaluates to false, nothing will be done. But if it evaluates true, as long as the condition is evaluated true, something will always be done. So the while loops enable your programs to repeat a series of statements over and over again, as long as a certain condition is always met. Because that expression determines when the loop finishes, the body of the whole loop must change the variables used in test expression. Because that expression determines when the loop finishes, the body of the whole loop must change the variables used in test expression. Otherwise, text expression never changes, and the whole loop repeats forever. This is known as an indefinite loop, which you must always avoid in programming. The following is therefore an algorithm for this structure in form of a flowchart and a sample program for the while structure. It is for a program which calculates the area and the perimeter of a circle as long as its radius is less than 10. So this is an algorithm in form of flowchart for a program which will only compute area and perimeter of a circle for as long as the radius is less than 10. The first, we have start, we assign 3.142 to pi. Then we prompt the user for radius. Check the radius. Is radius less than 10? If yes, compute area, compute perimeter. Display area, display perimeter. Then prompt the user again for radius. Check the value of radius again. Is it less than 10? If yes, compute area, compute perimeter, display area, display perimeter. Then prompt the user again for radius and continue if it evaluates to false. So the loop will continue. The condition will always be tested. If it evaluates to yes, area and perimeter will be computed and be displayed on the screen. But once it evaluates to false, to no, that loop will be exited. So this simply means this loop may exit without any computation of area or perimeter. When will that happen? It will happen if once you begin, you key in a value of radius that is 10 or more than 10. So nothing will be done. The program will just end. So this is an example of such a program. That's a comment, or that is the name of the program there. Then the comment is it computes area and perimeter of a circle as long as radius is less than 10. Then we have, of course, the outstream. We have using namespace std. We have the main function there. We have declaration for our constant and assignment of value 3.142 to 8, which is pi. Then we are declaring memory locations called perimeter area and radius, as usual. Then we enter the radius of our circle. Why am I saying as usual? It's because, my dear students and the rest of the learners, before you do this part of the series, ensure you have gone through part 1 all the way to part 6 so that you don't struggle understanding what I'm trying to do. Then read radius there. Then check, is radius less than 10? So while radius is less than 10, compute area of the circle, display the value of area on the screen, then compute the value of perimeter, display perimeter on the screen. Then prompt the user for radius. My dear students and the rest of the learners, kindly note, you have to request the user to enter the radius before a determination is done on whether the radius or the value entered is less or more. Then within the radius, once the last brace for while is executed, the compiler will go again and check radius. Once you key in radius, it will check whether the radius entered is less than 10. If it is, it will repeat those set of activities and closed under the braces. But once it evaluates to false, that part will be exited and we shall go to return 0. The compiler will take back the control to the operating system and then the program will end. So for this structure, as you can see, area and perimeter will always be computed and being displayed for as long as radius is less than 10. So while radius is less than 10, as long as radius is less than 10, then area and perimeter will always be computed. Otherwise, they will not be computed and the program will end. So how do we code that in C++? The program, or how does it work? Let's see. So this is a demo of how that can be done. So we are going to click on File menu, go to New, then Project. Click Win32, Win32 console application. Then the name of my project, which I'll type here, will be while. While area peri circle. That means this is a program for computing area and the perimeter of a circle using while. Then I'll click OK. Now, I'm being told that unknown exists of the same nature, so I'll change it. So while, I'll have while loop, while loop, area peri circle. I'll click OK. Then I'll click Next. Click on the console application, empty project, and click Finish. Once we are here, I'll right-click on Source Files, point on and click New Item. And because I'm coding source code for while, I'll click on the code. Click on C++ file, and then here, type the name of my program. So I'll call it while. It is while loop area peri circle. While loop area peri circle. Remember, you are free to give them your names, any name you want, for as long as you can remember what it is all about. Then I'll click on and. Once I'm here, I can type my program directly here, but I'll not do that because of time. I'll copy my program from my editor. Remember, you can always type your program in an editor. So this is my program for while. As you can see, this is the flowchart I've already shown you. Then I can now copy my program. Right click on it, copy. This is for while. And then go to your editor and paste your source code there. There we go. So you can see from the comment here, this is for using while control structure. And once you have pasted your code here, you can always organize it properly so that it becomes more readable, like that. And then the rest can remain that way. So this is while structure that I've already demonstrated. So I'll save by clicking on save button. Click on build. That is compile. So we want to compile to whether our program is okay. Remember, compiling is converting your source code to object code for subsequent execution. So click on build solution. Let's see if our compilation will be successful. There we go. It is successful, as you can see. 0 failed. From there, we can run our program. So click on debug, then start without debugging. There we go. That's our output screen. You can see it is saying enter radius of a circle. If I enter 3, 2, and press enter, you can see our area has been computed and displayed, and the perimeter too. There we are. And then it is being displayed. The area perimeter has been displayed. If I press a key to continue, you can see I'm already being told enter a radius of a circle at the bottom there. So that is this statement. So we have to enter something. If I enter 6 and press enter, you can see the program will still compute. If I enter another radius, let me enter 9 and press enter, you can see the computation is still being done, and we are still being requested for radius of a circle. If I enter 1, you can see it's still repeating. If I enter 3 and press enter, it will still do, and I'm being asked for another radius. If I enter 7, it will still do. Now, you can see that in while repetition, there's a repeat in computing area and the perimeter for as long as what? For as long as radius is less than 10. So let me enter 10 here as my next radius and press enter. You can see that has marked the end of my loop, the end of my execution of the loop. No repetition again. I'm being told to press any key to continue. So once you key in a value which is going to evaluate to false, if this condition evaluates to false, then you'll be taken out of the loop. And that's how while structure works. The next iterative control structure in C++ is called do while loop. What is do while? It is also called do loop. This construct is similar to while loop, except that the relational test occurs at the end instead of occurring at the beginning as it is for while loop. This ensures that the body of the loop executes at least once before the condition is checked. Therefore, the main disadvantage with this construct is that execution will proceed even if the first value that has been entered is wrong or is outside the range that is required. Therefore, the do while tests for a positive relations test. As long as the test is true, the body of the loop continues to execute. In other words, this do while is similar to while. The only difference is that For while, we have checked before executing any statement. But for do while, we first of all execute some instructions, and then we check the condition to determine whether repeat or will not repeat. Its syntax is to execute the following statements, then check. So do A, B, C, D while the condition is true. So as long as the condition is true, you can always repeat set of actions. So you do something fast, check for the condition. The first statement is executed, and then the expression is evaluated. If the outcome of the expression is non-zero, then the whole process is repeated. Otherwise, the loop is terminated. The do loop is suitable for situations where we need the loop body to be executed at least once, regardless of the loop condition, before we check. So a do-while loop will always iterate at least once, regardless of the value of the condition, because the statements execute before the condition is evaluated the first time. The following is therefore an algorithm in the form of a flowchart and a sample of a program implementing this structure. It is for a program that calculates the area and perimeter of a circle for as long as radius entered does not exceed 10. So we have our flowchart here. You can see in this flowchart, once you have entered radius, we compute the area, we compute perimeter. We display area, we display perimeter, and then we ask ourselves, was this radius more than 10? In other words, before we end, once we have displayed the area perimeter, we request for the user to enter another value of radius. Then we check, as this value which has been entered more than 10? If yes, we exit the loop. But if the value entered is not more than 10, we repeat. So that means no. So we compute area, we compute perimeter, we display area and perimeter. Then we request the user for another radius. We check that radius. Is it more than 10? If no, we repeat, compute area, compute perimeter, display area, display perimeter. Then we request the user for another radius. We check. So this loop will repeat for as long as the value of radius does not exceed 10. Otherwise, once it exceeds 10, we stop. That means no. Now, when it comes to coding, my dear students, the rest of the learners, we code that way. We have, of course, the comments as usual. We have hash include our stream. Now, my interest is on the while section, the do while. You can see once you have entered the radius, then we check. No, first of all, before we check, we calculate the area. And then after we calculate the area, we display the value of area. Then we compute perimeter and display perimeter using the statement, the perimeter of this circle is. And then before we come out of that loop, or before we determine whether we are going to repeat or not, we request the user to enter the radius again, another radius. We did it. Then we check, we repeat, we check. Or once not we repeat, but once we have read the other radius that has been entered, we check. So we check. We ask ourselves, are the radius which has been entered less than or equal to 10? If yes, we repeat. But if the value of radius entered is more than 10, then the program will not repeat this set of statements, but exit. Then we write out a new line. Then we return back control the operating system and end our program execution. So the most important part for you to remember, my dear students, the rest of the learners that differentiate between this structure and others is this section for do. So you do and a do, you write the do, have the opening brace, expression for computing area, we display the area, expression for computing perimeter, display the perimeter. Then the other secret you need to remember is to request the user to enter radius before you decide whether to repeat or not. Within the radius, then you check that radius. If the radius meets the condition, you repeat. But if it goes outside of the required condition, the program ends. So this is a demonstration, or this how this program will look like if I code it in C++, editor, and compare from there. Let's see how our output will look like. So while we are here, we can click on new, file, new, project, Win32, Win32 console application. Then we type the name of our project here. This is now do while loop is for area and the perimeter of a circle. I will not change the location. I will already, because we have created directory for solution ticked, it will remain. So I can just click on OK. On this, welcome to Win32 application wizard. Click next. Add application settings, choose console application, empty project of the checkbox, and click on finish. Once you are here, right click on source files, point on add, click new item. We are writing source code for do while. So click on code C++ file. Then I'll type the name of my file here. And the name of my file is do while loop. It is area perimeter of a circle. And remember, you can give your name, any name that you want for your program, as long as you can be able to tell what it is all about. Then I'll click on and. Once you are on your editor, remember I've said you don't need to follow this entire process if you are not using Visual Studio 2010. If you're using another version, what is important for you to be able to load the editor? Once you have on the screen where you are able to type your program, you are good to go. So you may have fewer steps than the steps that I'm demonstrating with in this program. So you can type your code directly or you can copy it. So for me, I'll copy my source code from an editor. That is Microsoft Word. So this is my program which I've already typed here. So I'll copy this program for do while. Right click there, click on copy. And then you go back to your editor. Here we go. And then you can paste your source code here. There we go. This is my source code. You can see file name, do while area, perimeter of a circle. And this is our source code. It is our source code. You can see we have the C in, we have the C out, which prompts for radius. We did it. Then do, we first compute the area, we display area, we compute perimeter, we display perimeter, as you can see. And then before we end, we prompt the user for radius. We read radius there, and then we check if the value for the radius has to be entered is okay. So is radius less than or equals 10? So the repeat will continue while radius is less than or equal to 10. Otherwise, the control will be returned back to the operating system and the program ends. So let me click on save to save my source code. Once you are done, click on build, then build solution to compile your program. Below the output section, you see whether your compilation has been successful. Mine is successful. You can see build one succeeded. So my program has been converted to object code. Now I can execute it. How do you execute your program? You can execute it in various ways. If your program has executed, click on execute, then run, or run, then execute. For this, of Visual Studio 2010, you click on debug, then start without debugging, because my program has no errors. And then you can see where we are. We are being told enter radius of a circle. Let me enter 20 and press enter. You can see, whereas the condition is or radius is less than or equal to 10, already the first computation has been done. I already have my perimeter and the area on my screen, and I'm being prompted for another radius or for radius. So if I enter 2 and press enter, you can see it will still tabulate and display the results for me, as you can see. What about if I type 6? It will compute. Now, assuming I enter 11, will it still compute? Let's press enter and see. No, nothing has been done. The program has ended. So you can see the difference between while and do while is that the do while allowed us to compute the perimeter of a circle, yet the radius was not less than or equal to 10, as the condition is for the while. But once we have entered 11 and the condition is checked and found out that the radius is no longer, or the radius that had been entered is not equal to 10 or less than 10, the program has ended. And that's what do while works. We can now proceed and learn another control structure, iterative control structure in C++, which is it. So our last control structure for iteration in C++ is called the for structure. The for statement, also called the for loop, is similar to the while statement, but has two additional components, which are an expression which is evaluated only once before everything else, and an expression which is evaluated once at the end of each iteration. So the loop is controlled by three separate parts, which are initialization, a continuation condition, and an update. Therefore, the syntax for the for loop is for initialization, continuation condition, update, then block of statements. What does this mean? It can also be written as follows. We have expression 1, expression 2, expression 3, and then block of statements. The question is, what does expression 1 do? What does initialization do? What does continuation do, which is expression 2? And what does update do, which I'm calling expression 3? This is how it works. The compiler evaluates the first expression, which is initialization. It then proceeds to check the continuation condition to see whether it has been met. If the outcome is non-zero, then the block of statements section is executed. Non-zero means if the outcome is not true, if the condition has been met, then the set of statements below it are executed and the update section is evaluated and updated. Otherwise, the loop is terminated. Generally, the for structure works as follows. A program counter is first initialized. That means at the initialization, you set the first value. We call it the counter. Once we initialize the counter with a certain value, you proceed and check the condition if the value which has been entered is meeting the condition. If it is meeting the condition, or if that's okay, then you proceed with the execution of the block. So for example, the value of counter, that is initial value, is compared with the final value to see if they are the same. Now, if the comparison under the continuation condition evaluates to true, the block of statements inside the loop are executed. Otherwise, the compiler exits the loop. Once the last statement in the loop is executed, the value of counter is updated. That is, current value is altered by either increasing or decreasing it. Then the new value of counter is used in testing the continuation condition again and the process repeats. So my dear students and the rest of the learners, kindly note that the repeat continues until the continuation condition results to a value for terminating the loop. The general for loop is equivalent to the following while loop. Expression 1, that is initialization. So perform expression 1 while expression 2 is okay. It's like the do while. You perform a certain activity first, then you check the condition, and then you execute statements. Then perform expression 3, which is for update, and then you end or you exit the loop. Generally, the most common use of for loops is for situations where a variable is incremented or decremented with every iteration of the loop. The for loop enables you to repeat sections of your program for a special number of times. It is a determinate loop. This means when you write your programs, you can usually determine how many times the loop iterates. The for loop repeats until a count or a countdown is reached. After the final for loop count is reached, execution continues with the next statement in sequence. The for loop is a helpful way of looping through a section of code when you want to count or some specified amount. The syntax for loop can also be written as follows. For start expression, then check the value of first expression with the test expression. If that meets the criteria, perform certain number of statements or a block of statements, then update the counter. So C++ evaluates the start expression before the loop begins. Typically, the start expression is an assignment statement, such as assign 1 control or to counter, but it can be any legal expression that you specify. C++ evaluates the start expression only once at the top of the loop. In other words, the initialization condition or the initialization section is only executed at the beginning. Once it is executed, it is not repeated again. What is always checked is the continuation condition, perform set of activities. If that condition is met, then update the counter. Check the continuation condition again. If it meets the criteria, execute the statements, update the counter. Check again the continuation condition. So that continues until the value for exiting the loop is arrived at. So C++ evaluates the start expression only once at the top of the loop. Every time the body of the loop repeats, the count expression executes, usually incrementing or decrementing a variable. We call that updating the counter. The test expression evaluates to true or false, then determines whether the body of the loop repeats again. A sentinel can be used in a for loop for purposes of terminating it. A sentinel is therefore a special value of an input variable that is used to terminate the input loop. In C++, we can also have a for loop inside another for loop. Such a loop is called nested for loop. Therefore, a loop inside another loop is called a nested loop. The following is therefore an algorithm in the form of a flowchart and a code for a program that calculates the area and the perimeter of a circle whose radius ranges between the smallest to the highest radius of your choice. The program then displays each radius, perimeter, and area. So this is our flowchart for loop. We initialize pi to 3.142. Then we key in the beginning value and the terminating value, initialization value, and the last value. Then we assign initial value to radius. We check if radius is equal to the end radius. If not, we compute area and we compute perimeter. We display area, we display perimeter. Then we increment the value of counter. the value of radius with 1. We assign that value, the update, to initial radius. Then we check, is the value of initial radius equal to radius? That's the continuation condition. If that is met, or once we initialize, and then we check if the value of radius is greater than end radius, and we find it is not, we compute area and perimeter, we display area and perimeter, then we increment counter. And that continues until when the value of radius is no longer greater than end radius, and the loop stops. Now, the following is an example of such a program. I want to go all the way to the part where we have the for loop. So after you have entered the initial value and the end radius, we check. We initialize first radius with initial radius. We initialize. And then we check, is the value of radius less than or equal to end radius? If yes, we compute area and we compute perimeter and display perimeter and area. Now, that once the last brace is reached, the end radius or the radius is incremented with 1. Then we check, is the current value of radius equal to or less than end radius? If yes, we compute area, we compute perimeter, we display them, we increment the value of radius again with 1. Then we check, is the value of radius less than or equal to end radius? If yes, we repeat that. Once we reach the last brace, we check, we increment radius with 1, and then we ask ourselves, is the new value of radius less than or equal to end radius? If yes, repeat those statements again. When we reach the last brace, the closing brace, we increment the radius again with 1. Then we check, is the value of radius less than or equal to end radius? If not, we exit the for loop. Control is taken back to operating system and the program ends. How do we do this in C++? Now, this is the code. Now, let's see how the output will look like in C++. So as usual, let's start our editor in our C++ program. So with that two console application, my project now will be called for loop area of circle, and click OK. And then I'll click next. I'll select console application, empty project, click finish. On this screen, I'll right click on source files, click new and then new item, choose source code, click C++ file, and the file name I call it for loop area of circle. I'll then my location and click on and. From there, I'll copy my project. I'll copy my source code. So let me go to my source code. Here is my source code for the for loop. So I'll copy that source code and paste it on my editor. That way. And I'll proceed and click on build solution. So we are compiling. Let's see if there's any error. There is no error. You can see our compilation has been successful. So just ensure you copy the code as it is, as I've demonstrated in the presentation. From there, we can debug, that is execute our program by clicking on start without debugging. Once you are there, let's enter the smallest radius of the circle as the first statement there. Enter the smallest. So I'll enter 1, press enter. Enter the highest radius of the circle, I'll press 6. If I press enter, you can see that our program has computed all the radiuses, all the circles, with radius 1, 2, 3, 4, 5, and 6. And once 6 is reached, the program ends. Press any key to continue. Let's run the last one. You can see here we are. Now, enter initial radius. We enter, I will now want to enter 8. And our last radius, the circle that we want to compute the last radius will be 13. Then press enter. Now, we have exited the loop. Let's repeat again. I have pressed somewhere by mistake. Start without debugging. So let me enter 7. And the radius is not supposed to be what? According to our program, we are supposed to enter the first value and the last value. Let me enter the last value as 10. And press enter. So you can see the repetition continues. All the circles with radius ranging between there are computed and displayed on the screen. And the program terminates when the initial radius, or when the last value of radius equals to the end radius, that is 10 to 10. Press any key to continue. And that's how the for loop works. Always remember to save your work. And with that, my dear students and the rest of the learners, we have come to the end of part 7 of the series. You can now continue to part 8 of the series, in which you are going to learn about the functions. Congratulations for learning part 7 in C++ computer programming series by the title Iterative Control Structure. You can access the rest of the parts in the series, as well as other computer or ICT videos, by clicking or tapping on EmilySwap ICT YouTube channel below this video. To subscribe to the channel, tap on subscribe button below this video in YouTube if it's not currently reading as subscribed. For any further correspondence, kindly write it to us through the email emilyswap@gmail.com. Thank you very much for listening to me. Let's meet in part 8 of the series, and God bless.